So thanks for inviting me. Mike and Felix are really supportive, and yeah, I really enjoyed the process. So I will be talking about Bit by Bit developers platform. I'm the founder of it, and we will see how it leverages Gaussian splatting. And the presentation is called Augmenting CAD with Gaussian splatting. So we will talk about two things, and that's computer-aided design, right? The things that we create through algorithms like doing extrusions, chambers, fillets, and by that we create solids. And then there's this new kid in the block, right, called Gaussian splatting 3D scanning technique, which allows you to bring real-world objects into 3D environments. And this just provides another level of realism in your scenes. So 3D Gaussian splatting in CAD software, it can do many things, of course, but first of all, it improves realism. It helps in design process because you're dealing with real objects, so you sense the scale better, the colors better, and fundamentally, it just engages people in different sort of level, right? So this is really nice to have in the tool set nowadays. And on the other hand, computer-aided design, it also helps to manage Gaussian splatting. You can compose multiple splats in one scene. You can make splats interactive, use them in simulations, games, enrich them with bounding boxes, do these kinds of things that maybe you need some sort of additional tooling for. So what is Bit by Bit? Bit by Bit is a 3D platform that helps to program procedural models and experiences. And that at the end just saves time. You don't need to manually compose your 3D scenes. You can just expose certain variables that adapt your models. Bit by Bit itself, it combines many open source technologies like BabylonJS, OpenCascade technology kernel, GSCAD. It bundles them in one package and exposes into intuitive sort of experience to users, which allows them to create 3D models that they can then 3D print, manufacture by laser cutting, for example. You can also export the scripts themselves to your own websites. And just recently, we launched 3D Bits app for Shopify. So you can integrate the 3D models and experiences into Shopify quite easily. So bit by bit, technically, I will not go into much detail, but basically how it works is that computations on geometry, they happen in those CAD kernels that are quite complex. You need really PhDs to build them. So we don't build kernels, we integrate them into a coherent whole. So like GSCAD and OpenCascade, they serve as the base for modeling. And then the BabylonJS game engine is really a powerful web technology that draws everything on the screen when you're finished with your sort of computations on the geometry. So when you're finished with, let's say, applying Boolean difference operations on the geometry, and then you draw that finished result on the screen. And that's where also Gaussian splatting exists on the BabylonJS side. And we'll talk about that in demos as well. So we have 3 editors. I will not go into detail. We'll see that in the demos themselves, but we have like Read editor where you connect algorithms by using wires. We have Blockly editor where you compose blocks together. Those are 2 basically visual programming editors that we expose to users. And there's a third one called Monaco. And there you can just type TypeScript natively on the browser as well, and to create 3D geometry and use our algorithms. So enough of 2D, let's get into 3D and let's get to see some demos. So I'll start with a few projects that you may have seen already, and I prepared some fresh presentations for later. But basically, this is a script written in Read. It's graphical. You see that there are many blocks of code here, and you just connect them with wires, and these connections create sort of constraint logic of your script. And in this case, we have a palm tree, a Gaussian splatting 3D scan, and then parametric table designed in CAD algorithms. So what happens is that you can expose certain inputs that control, for example, how many legs this table has. And I can just drag this slider, and then the model recomputes. So you get immediately a new geometry without the need to remodel it manually every time. And I can change, for example, the table height, and it will recompute and make it smaller, so 0.5 meters, for example. And I can bring back, maybe 40 legs, and that takes a little bit of time to recompute, but just stay with me and it will be finished in a second. So yeah, you see that it just sort of recomputes, adapts the model again, and solves all the geometry correctly. So in this case, Gaussian splatting is involved in the CAD system just statically. Basically, it's just sitting there doing nothing at the moment, but we'll see examples where that is a bit different. So I'm Lithuanian. We have this old BMW that I just scanned for this presentation, and I thought, how could I combine CAD geometry that I already had in some of my scripts with this model? So this is not the best, 3D scan. Cars are quite difficult to scan, but yeah, it worked out at the end. And I had this script of alloy wheel that I prepared quite some time ago. It's parametric as well, so you can control how many, what's the size of the wheel, do various kinds of manipulations on it. But what I did is I just wanted to see how far I can bring this, and I just now was able to have a 3D scan with wheels, with closed doors, then another scan with open doors, and then in Super Splat Editor, I was able to remove the wheels, and let's see how that looks like. So this one is without the wheels, right? It's a bit, yeah, it doesn't look really good, but when I enable the wheels, the alloy wheels, the new ones, the virtual ones, then I get to see this sort of model that is already looking a bit better. And then I can play around with this model. You can go into the inputs that are responsible for creating the wheel itself. And I can say, maybe let's first put those wheels outside the car. Let's make that, let's bring that to outside the model. Then we can also make them a bit bigger, for example. Yeah, so this is maybe something that could be used, for a game or something. This is looking already quite interesting. Then we can also increase this slider to, for example, increase the number of, the number of these parts in the wheel itself. So yeah, you can play around with it. You can see various kinds of results. You can involve another splats in the scene. And this is an example that just shows the possibilities of how the Gaussian splatting can be combined. And you, of course, see some custom plate design on the car itself. So this is a bit, this is an experimentation sort of project. But let's go into something different. In this case, splat is used also parametrically. You see those plans on the table, and it all is also driven by some sort of logic within the script. And let's say I want to just change the table height. What will happen is that, yeah, I did it and everything just adapted, right? So I didn't need to remodel the legs. I didn't need to reposition where the splats are on the table. And all of these 3D models are also, like, for example, these vases are 3D printable. So subscribers to our platform can download them and just 3D print them, manufacture them, put them on the table and have it in there. So in this case, Gaussian splats also just work to improve the realism, and CAD helps to manage them in one's environment. Here we have a Blockly script. So this looks a bit different, right? In Read, we had those wires that connect algorithms. And here we have blocks of code that encode the behavior of your program. And it's still visual, so beginners are able to find these blocks, maybe easier to use. This is also familiar more to people who are used to Scratch and tools like that. These are learned in nowadays, even in schools, by children. But we brought it to a bit, maybe more adult level with these professional CAD algorithms. And here, Blockly encodes more things as a real game engine. So you can encode behaviors, right, like rotations. These flowers, you see that also are composed in the circle. So the circle rotates and then the plant itself rotates within the circle. So you can use many coordinate systems that are nested together. to create these kinds of experiences. Another thing, this is just a showcase. This doesn't show the Gaussian splatting themselves, but just to prove that Blockly can be used to even code, game behaviors. Just lacked a bit of time to change that plane model to something that is coming from Gaussian splatting. But here you can just see that I'm flying the plane, I'm popping those bubbles, and the score is counting. And at the end, when minute will be over, I'll be presented with a score. And yeah, then basically the game will be over, and I will have some numbers on my screen. So basically, the editors that we provide, they can encode behaviors, but also you can almost compose games and simulations and serious things with it. So in this case, we have Monaco editor, and here we see just pure TypeScript, right? You can interact natively with Babylon.js, with our CAD algorithms and everything. And we built this Havoc physics-based simulation where Gaussian splatting models are now interactive. We've built collision bodies for these splats, and you see that I've scanned myself here, and these are now interacting with each other, falling apart. And yeah, that's also how the splat can be integrated into game engine simulations and all kinds of experiences on the web. So this is the latest example of that we built specifically for this meetup. I just wanted to show some better worked out example of 3D model that uses Gaussian splatting. And in this case, we see a bike stand holder that is also serving as a bit of a plant, growing mechanism. So we have this roof that collects water. The water goes into this pipe, and then it shares the water with the plants. And we have bikes standing in a circle. And yeah, there's my wife as well here that was put in the environment. And what's best is that this whole script is also parametric, which means that you can control it through these sliders again. And you can expose whatever you want, of course, but in this case, you can say, okay, I want 20 bikes, for example, to be here. And you don't need to remodel anything. We just adapted the model immediately to have 20 bikes. If you are interested in having 3 bikes, so way less, let's do that. And you see that it's recomputed. It managed to solve all the geometrical sort of constraints to position those bikes correctly. You don't need to manually rotate everything and remodel it just because there's some sort of small parameter changed in your wishes. And maybe you also need a kid's bike and not adult bike, and that's also possible. So this is a different splat that gets loaded into environment to just see a different result for your parametric model. So what's nice about this is that these scripts that you write in bit by bit, you can export those to runner. And you see that here we just generate JavaScript. That JavaScript can be copied and pasted into wherever you want into your index.html file, as a script of JavaScript. But what we did, we prepared this StackBlitz editor, this third-party editor. We have nothing to do with StackBlitz itself, but we use it just to demonstrate that the code just can be executed on a different platform. So we wrote a small UI here that also controls those same variables. And we can change the number of bikes by dragging the slider. You can, by the way, visit this link. I think it should work for everyone. You can play around. And then basically, it also has this option to switch the bikes. Everything recomputes. And the same code we have exposed here on CodePen. So that's another third-party coding website that just has native HTML, CSS, and JavaScript. So if you're a developer, you will know what to do with it. It's quite easy, and you don't need any cloud services, anything. It just all runs on the browser. It does require, of course, for you to run Babylon.js and include the bit-by-bit runner.js file, but that's it. That's how easy it is to get these experience outside our editors into something different. So having said that, there's also a new solution that we released just last week, and that's 3D Bits app for Shopify, where you can also integrate those same experiences that I showed you before. So in this case, we have the same bike holder here, and what you can do is link those inputs. So for example, you as like a customer of this shop, for example, you're maybe interested in purchasing this whole system, and I will be the one who's manufacturing it, or I'm the merchant, let's say. And you can choose, for example, how many bikes you want, and the product updates, the price updates, you see immediately what you will be buying, and those splats, they just help you, to visualize, to bring this realism to your customers that are just closer by. And you can just add it to cart, of course, and go to checkout. So this is a demo store. You can also visit it. It's behind the password, and it's 3D-bits-demo. You can use this link that you see here on the screen. I will later probably share all the links anyway. But yeah, so there are more, products here that you can check that are also meant to visualize various kinds of aspects and possibilities. So if you're selling, maybe some dress, for example, you can use real world humans to wear them and integrate them in your Shopify stores quite easily, by tweaking some settings in our application. Okay, so this was it. I invite you, like, for the demo part, I'll finish with a few slides as well. But just visit our projects page. You can find all of the projects seen today here. The green marks indicate that they are free for everyone, so it's under MIT license. You can check them out, open them up, run them, inspect the code. I advise to use laptops or desktops. It's just much easier to interact, and phones can just be a bit too fragile for this UI, basically. But yeah, the shop itself, for example, from 3D Bits, you can open in iPhones and run the products themselves there. Let's see one more thing. Yeah, so here are also 3D models that we have provided for you, which you can check as an example of what you could build by using our algorithms. So here we have, for example, furniture configurators. It's in L shape, for example, and you can enter your own dimensions. This is a custom-made app that uses also our algorithms, but then UI was built specifically for this purpose of configuring terrace furniture, right? So you can then, visualize dimensions, do these kinds of things, change inputs like this. Yeah, so everything adapts parametrically. You don't need to remodel, and you can just at the end, check how many planks do you need to go and buy in the store. Okay, so I'm going back to the presentation, and there are just, I know I don't want to bore anyone with these kinds of slides, but I will just show it to you so that it would explain a little bit better how this vertical stack can be used by you, depending on where you are in your web development journey. So what happens is that Bit-by-Bit developers platform itself, it has this proprietary layer, but because we use a lot of open source technologies, we also try to contribute to the open source community. And we have this whole core NPM library list that we expose to you. So if you're a Node.js backend developer, for example, you could tap into this Bit-by-Bit dev OST NPM library and use it in your backends. So you can then run the algorithms not then on the browser, but in the cloud. You can, of course, use OST Worker, for example, in game engines that are not necessarily Babylon.js. So we have some examples that use 3JS. We don't have Play Canvas examples, but yeah, you could theoretically integrate draw methods for that and use it there. And Bit-by-Bit Dev Core is meant for someone who's already familiar a bit with Babylon.js maybe and is fine with this engine. And it contains all of our core algorithms that are also exposed to the runner. And the runner was the technology that we used for Shopify and all kinds of things. So I invite you to check this slide out later on, when you will be maybe processing how you could tap into our platform. Yeah, I need to thank to all open source contributors of the technology that we use, and I did not even mention all of them. And special thanks to Cedric. He's the brain behind the Gaussian Splatting in Babylon.js game engine. He brought it in there, and then I was able to use it as well. And huge thanks to all of you, of course. So don't hesitate, reach out to Matas at bitbybit.dev whenever you want. Yeah, I'm there to help you in your web development journey of 3D models and applications. And yeah, just visit our homepage, check out social media. Yeah, we're there. We're constantly there. So thank you.
Thanks so much, Matas. That was really, really interesting. I want to open the questions to the audience. So if anyone has questions, there's a Q&A tab or button you can use, and you can ask your questions. But in the meantime, I have some sort of basic questions, and forgive my ignorance, but can you explain what a parametric means?
Yeah, so parametric is sometimes just interchangeably used with procedural. And parametric means that you define those logical constraints that drive your model. So you don't start with manual labor, like let's say, indeed, you would like that table to get higher, right? So normally, if you are using just manual modeling techniques, you would go and actually, shift the leg up, probably shift the other leg up. I mean, you can be smart about those things in many of the software systems, but still fundamentally, you do a lot of manual labor and it's time consuming. Parametric design and procedural design just helps you get those results faster. You just expose critical variables that you want to control and force your model to adapt to those. And that just saves time. Basically, it's about time saving, about being a bit smart. So maybe you just configure certain things that you are manufacturing, and the rest can be maybe static. It depends what's the purpose, but yeah, that's a bit how I think about parametric. It's about parametric relationships between different algorithms.
Okay, that makes sense totally. I think in some of the CAD I've done, I've been using parametric tools, but maybe not realized.
Could very well be, yeah. It's not something definitely crazy new, yeah.
Okay, and then so we're getting some questions in the chat. So let's see. Let's start with the Shopify. I think everyone's really interested in the ability to bring Gaussian splats into Shopify. And so the first question is from Yoshi Sato, and he asks, when showcasing a 3D.js model on Shopify, where would I need to host 3D.js model? Would I need to upload the model to your server?
Not necessarily. So actually, I would even advise to host it on Shopify's file system, because you can upload up to 20 megs there. I get that, some splats can be way higher, and then there's a question. But if it's up to 20 megs, and can also be smart, how you load them, maybe just combine few files, for example. But in principle, Shopify offers file system, and it's available then through CDN. So it also gets optimized for, wherever you are in the world. It will load it faster, and you will just use that link in the script of, for example, bit-by-bit, and copy it to Shopify, and then it will load it from Shopify CDN file store. And that file store is just linked to your shop. Basically, you have an account on Shopify, and you can upload up to 20 megs. I'm not sure. Maybe Shopify itself has a different plan tier, that maybe has a higher hosting level for files. But you can also use, alternatively, there's also a possibility to use bit-by-bit itself for our cloud services. But we also have some limits. We have 100 megabyte limit per file at the moment, for example. So yeah, but you can also use your own hosting, maybe. It's what we require is a link that is available to load the file.
Okay, and then sort of related, there was a question about loading times on Shopify and how that might impact search engine rankings. Do you have any sort of feedback on that?
Yeah, so I honestly, I didn't really test it. There will be an impact, of course. What we allow to do for the users, for example, if you're just loading the splat file, and you don't need the CAD geometry kernel, then we allow you to choose to opt out from this CAD geometry kernel. So you say, okay, I don't need that, and then a lot of that will not be loaded. So then performance time when loading will be only impacted by Babylon.js basically. So you load that. But also while you load the canvas, we display the image. So I'm not exactly sure, like time to first draw, for example, I don't think it will suffer because you will be showing that picture in the beginning. So I'm a bit scared to say something
Yeah, sure, I
completely, but
understand.
yeah, but I mean, you can also maybe have, I don't know, alternative page, one with 3D model and configurator, another just with pictures, for example. But yeah, I will have to test that out. It's a bit fresh solution, so I'm not also totally up to date with this part.
Sure, no problem. And I was really, something I'd never seen before was the interaction of, I guess, polygonal 3D models with Gaussian splattings. You showed the physics of hitting those scans of you. Can you tell me more about how you did that? Because my understanding was that, unlike a textured polygon, the Gaussian splat doesn't really have a surface with which to calculate those things. So can you talk a bit more about how you made your Gaussian splats interactive?
Yeah, so it's nothing new in game engines, right? So what happens is you never usually use very detailed meshes for collision detection, for example. You always try to, because collision detection is very intensive computational, process. What you usually do is you reconstruct something similar to that body that you will be interacting with. You make it invisible, but you force Gaussian splatting or very detailed mesh to just follow the interactions that are being caused by hitting that raw mesh, right? That is not very detailed. Sure. And basically Gaussian splatting then just hits this invisible body that was abstracted away. It's invisible, and then it just follows those interactions in 3D scene and re-renders, and everything just looks fine at the end, right? So more or less, I mean, the more detailed you want, the more detail you need, the more detailed your abstraction needs to be, the more closer it needs to get to the body that you will be interacting with. So it's a bit of a play through, and that's where maybe nerfs could also be coming handy because they do provide you with this mesh representation of splats, not splats, mesh representation of objects basically, which is a bit different than point clouds. Yeah.
So that sounds really interesting. So people can use their sort of traditional techniques of bounding boxes and stuff
like
that
exactly.
They use for normal game design and just apply that to splats to do that physics. Okay, really interesting. So we've hit time. I don't see any questions active in the Q&A. So thank you very much for that really interesting presentation. And there was a question which was there and then disappeared and was asking whether you could provide some of the links that you discussed.
Yeah, I'll try to just throw them here in chat now, and later on, I'm not sure if we will be composing everything maybe together to some blog posts. I can also then put it there, but I will provide them in chat just after the presentation.
Okay, fantastic. Thank you so much.
Yeah, thank you.